Throughout the world, people go to extremes. There's amazing ingenuity and some stuff that's mind-bogglingly dangerous. Some people push the limits because they have to. Others because they choose to. In this episode of The World's Most Extreme.
There's something innate about our need for speed, our need to create the fastest, biggest, most awe-inspiring vehicles there are.
On 2 wheels, 4, or none at all. On the road, in the rough, or even places that seem impossible. These are the world's 10 most extreme. To harness as much energy as possible from wind, you need to build your turbines big. And to build bigger, you're going to need a bigger toolbox. At Jever wind farm on Germany's North Sea coast, a new turbine is ready to be put together. The rotor's diameter is almost the length of a football pitch, and it weighs over 125 tons. Just as well, then, that the team here have this. The world's tallest and most powerful mobile telescopic crane. The catchily named LTM 11200 9.1. Let's call it Big Red.
You see boom cranes on a lot of construction sites, but this is in a class by itself. Much bigger than a typical boom crane. With extensions on that boom, it can lift something up to 50 stories above the ground.
Der Kran hat eine maximale Hubkraft von 1200 Tonnen. Im Arbeitsbereich wird man mit diesem Kran wahrscheinlich so um die 500-600 Tonnen heben können, weil 1200 Tonnen ist ja ein theoretischer Wert, aber er ist halt in der Lage, das zu leisten.
That's the weight of nearly 100 London buses. Today's job is to lift the rotor 60 meters up and fix it into place on the new turbine. But the team need to move fast. Turbines need steady 10-mile-an-hour winds to work efficiently. The North Sea feeds Jever's turbines with an average 10 to 20-mile-an-hour winds throughout the year, which is perfect, unless you're building one. If the wind speed rises above 13 miles an hour, the job will become too dangerous. It's not a problem for the crane, which can operate in high winds, but the rotor is designed to catch every breath of wind.
Da muss man sich im Vorfeld schon informieren, beim Wetterdienst oder wie auch immer, dass die Bedingungen bei einem so einem Hub, wie wir das jetzt hier hatten, dass das dann auch sicher ist.
This morning, the wind speed is already at 10 miles an hour and due to rise to 22 miles an hour by the afternoon.
Anytime you're lifting a load out, the farther it goes from the base, the more it wants to pull the crane off balance. There have been many terrible accidents over the years with cranes falling over because they tried to lift a load too far off axis.
To keep its load within its base of support, Big Red stretches its legs by up to 5 meters each. It's one extendable, adaptable multi-tool with over 1,000 different configurations, including an 8-part boom that extends to around 100 meters for the biggest jobs. Today, it's been fitted with its 3-part telescopic boom. Wind speeds get faster with altitude, so the higher the rotor goes, the more the wind buffets it. The rotor locks into place, secured by ropes, whilst the nose cone is fixed to the assembly. The heavy lifting is done, but now the guide ropes need to be released from the blades. Work for human hands.
Wir teleskopieren den Kran jetzt noch mal 6 Meter weiter aus, damit wir es leichter haben, die Seile abzumachen. Und dann machen wir als nächstes mit dem Mahnkorb die Seile ab, beide ab.
With the wind still rising, Big Red carries its most delicate cargo. It now becomes a precision tool. The team need to be positioned perfectly to cut the ropes. And the ropes are released. Job done. Which means it's time for the final tool in Big Red's box. A set of 18 wheels for driving it to the next job. But even a 100-meter tall crane won't do if your job flies 240,000 miles high. This is where NASA has built its rockets and shuttles. But it launches them 3.5 miles away. So how do you get from here to here?
And liftoff.
The Kennedy Space Center, Cape Canaveral. In the 60s, the US was desperate to beat the Soviet Union to the moon. But before they could tackle that 240,000-mile journey, they had to figure out a 3.5-mile one.
What you've got to be able to do is take the Saturn rocket or the space shuttle from what they call the Vehicle Assembly Building, or the VAB, to actually the launch site.
In 1965, NASA spent $14 million on the solution. The biggest self-moving vehicle in the world. For half a century, NASA's 2 crawlers have given a piggyback to all of their shuttles and rockets, including the Saturn V, which in 1969 helped them finally socket to the Soviet Union by launching man to the moon. In doing all that, each one has racked up over 2,500 miles without ever really going anywhere. Each crawler is about 3,000 tons of kit, which can carry over 8,000 tons on its 35-meter wide, 40-meter long back. The only thing that isn't massive about it is its steering wheel. That's about 15 centimeters diameter. That's one small steering wheel for one giant rocket carrier. But it needs to be a gentle giant.
Rockets cost millions and millions and millions of dollars to put together. You don't want to essentially have an accident moving it from the assembly building after years of painstaking assembly work. So this is a really heavy load that they're going to move, and they move it very slowly.
By slowly, she means less than 1 mile an hour. About as slow as a sloth in a hurry. The whole journey can take 7 hours, with a crew of 30 working in shifts to ensure a wobble-free ride. Even the 40-meter wide track has been cautiously engineered.
They've made the roadway out of rock that comes from Alabama and Tennessee riverbeds, and it's really low friction. And what they're trying to do there is to minimise the chances of any sparks developing as the shoes move across the rock, because clearly when you've got a rocket full of rocket fuel on a mobile platform, the last thing you want is sparks that might ignite that fuel.
The river rock is rounder and smoother than your average stones. They act like ball bearings to help those huge steel tracks glide along. A water truck leads, damping down any dust that could damage the multi-million-dollar equipment, which the crawler needs to keep perfectly level.
One of the challenges they've got is making sure that they don't tip it. Even though they've got about a 10 degree of incline from the building to the launch site, the platform can be adjusted so that it's never more than 0.16 of a degree.
Staying perfectly level isn't helped by a ramp at the end of the track, where the launch pad is raised to create space for its huge flame trench. But this beast of burden has it covered. The crawler uses laser guidance and a hydraulic levelling system to tilt the platform and keep it within that 0.16 degree margin. On the 5 degree ramp, the back shifts up by as much as 1.5 meters. To keep a load as tall as even the 111-meter Saturn V dead straight. within a margin of less than a metre at the top. The crawler can move millimetres at a time to position its load before scuttling away to escape blastoff. After the space program ended in 2011, the crawlers were due to be sold and doomed to be dismantled. But it seems these relics of the 60s space race can't be bettered. They've now been recommissioned and upgraded to carry the new Space Launch System rocket, which could one day put humans on Mars. But if you've got the right set of wheels, you don't need a spaceship to go to Mars. Or what looks like Mars, the red rocks of Sedona, Arizona. It's cowboy country, but the guys in saddles here aren't on horseback. And it's also great for mountain climbers because of its otherworldly giant rock formations. Bell Rock, a whopping 1,499 metres high. The mighty Cathedral Rock, 1,514 metres. And... oh, I don't know that one. Of course, you wouldn't want to cycle up anything like that. But he would. In the heart of Arizona, on one of Sedona's near vertical slopes, the White Line, known to some as the world's most dangerous bike trail.
Just like skiers or rock climbers, mountain bikers are always looking for that slightly more extreme, more exciting situation. The White Line Trail is kind of the ultimate example of this.
That line isn't a paint job. It's a natural streak in the red sandstone rocks. A go faster stripe, leading daredevils like these on a vertigo-inducing, gravity-taunting minute of what most would call hell. But not Polish pro biker Michael Kolbeck.
When you just start rolling, you have this weird thought in your mind, should we do it? Should we ride it?
For most people, that weird fuzz would be a crystal clear no. This is Michael on the outbound stage.
This is the most technical stretch of the ride. Riding on super off-camber rock and your tires are constantly sliding to the side.
So kind of like...
Holy crap! All right, I need to let out a little bit more air pressure then.
maybe a little. If he'd fallen to the left, that would have been curtains. But that's not even the scary bit. Here's Michael again.
Second stage is definitely the most terrifying stage of the ride. It's super steep and you can't see anything besides the cliffs. Your mind's going crazy and you have only a couple meters to make a 90-degree turn before you can just fall down the cliff. Like any bigger mistake could end up very badly for you.
By very badly, he means dead.
At first glance, it looks totally suicidal. In the hands of an experienced rider, you can control your position on a steep slope literally within half an inch. These riders, they're more in control than you might think. What makes it extraordinary is the fear factor, or what mountain bikers call exposure, and that is the penalty of a mistake. If you do make a mistake, if you do fall, you're going over the edge.
And that's reason aplenty as to why you should not try this yourself. It's frightening enough for pros like Michael.
This one was definitely scary, I can remember it now.
It would be rather hard to forget. In this factory, engineers are hard at work, building something big. No, not these little dumpers. Something much, much bigger. The Belaz factory in Zodzina, Belarus, has been producing mining and haulage vehicles for the past 70 years. Tough dumpers that carry huge 350-ton loads around mines in some of the world's harshest territories. But in 2013, they decided to up the ante. with the 75710. Over 20 meters long, 8 meters high, and 9 meters wide. But the headline is that it can carry 450 tons, 100 more than its little brothers. But just building bigger doesn't solve all the challenges that come with shouldering such massive loads.
The problems that you have with this particular vehicle is that you have to have very high power engines. This particular truck uses two 16-cylinder diesel engines. It uses lots of fuel.
Your average family car gets around 50 miles to the gallon. The 75710, about 0.2 miles to the gallon.
It's a diesel motor powering an electric generator, and that power from that generator goes to electric motors that drive the wheels. The reason they choose this electric propulsion is that at very low speeds, you have a lot more control. You don't need to have lots of gears and clutches to get this incredibly heavy truck rolling.
So you got the power, but then you need to carry those 450 tons of back-breaking earth, plus the 360 tons of the Bellaz's own weight, without digging into the mud.
The tyres are often the limiting technology for these trucks. You've got to be able to hold the weight of the load and the weight of the vehicle itself on the tyres. And these tyres cost tens of thousands of pounds.
Wider, tougher tyres help spread the load, so you don't get that sinking feeling. But your other load-carrying problem is that those mines can be pretty rough and slippy.
One of the things that you do to make this truck effective is you have differential drive on each of the wheels. That allows you to have good traction in very different conditions.
This all-wheel drive option also means that if one of the electric motors breaks down, you can still use the others to drive back to the garage.
One of the things about mining, it's a very competitive industry, so the cost really matters. So if you can have one big truck that does lots of the operation, then that's a way of being more efficient and getting more profit back from the commodity that you're mining.
So in mining, one way to get more bang for your buck is a bigger bucket. But there's tough environments, and then there's Tornado Alley, USA. Every year between March and June, more than 1,000 twisters can wreak havoc here, causing billions of dollars worth of damage. To combat this problem and protect lives, you need up-to-the-minute detailed intel on exactly when, where, and how a tornado will strike. The solution might be in this garage. In Springfield, Missouri, a crack team of tornado trackers are about to unleash 2.5 tons of reinforced steel machine designed to penetrate a tornado and gather essential scientific data.
Tornadoes are some of the most powerful things on the Earth. And if you want to get inside of one, you need to go in heavily armored.
Okay, it's quite small, but bear with us. This is the Tornado Puncher. Other tornado-penetrating scientific data-gathering vehicles are available. Today, consultant engineer Russell Gerke and his team are going to put their new vehicle to the test. It'll need to be tough enough to face some epic forces.
Within the tornado itself, wind speeds can be in excess of 300 miles per hour. This is a very tight, strong rotation of air.
The amount of energy in a decent-sized tornado over its course is about a terajoule, which is the same sort of ballpark as 1,000 tons of TNT.
Which is enough energy to turn everyday objects into missiles and launch trucks into the air. The team have spent $80,000 converting a 1977 Chevy into a virtual tank.
The majority of the puncher is built out of 1/4-inch steel, carbon steel, and then it's got a coating of this polyurea, and they put it on buildings to make them blast resistant. The military uses this material.
So it's tough, but how do you stop it being hurled 30 meters into the air?
It's got to be heavy, as the weight is your first defense against the wind lifting it and lofting it.
That's 5 tons of heavy when fully loaded up.
Then two, you want to be able to have the angles to get the wind to help push it down and the wind to move over it.
So its shape should act like a spoiler and let wind flow over and push it down.
The airbags, it lifts us up to gives us clearance. So if we're in an area where the road is full of debris or whatever, we can get higher, and then we can release the air out of the airbags and lower everything to the ground.
So we know what it's made of, but how do you test a tornado-proofed car? First, the team are going to see how that airbag-assisted suspension takes a beating by driving over the puncher with a 2.5-ton rock crawler.
5,200 pounds of rock crawler. 5,200 pounds, that's good. His rock crawler proved well that the suspension is tough.
Test 1, tick. Next, the tug test. The team want to calculate how much tornado force the puncher will take before being overturned, using the rock crawler as a stand-in for the tornado.
We're comparing the force of the wind to the force of the pull test.
150-mile-an-hour wind would be an EF3, according to a scale devised by scientists. And here's one to explain what that means.
The strength of a tornado is measured with something called the EF scale, which ranges from EF0, which is just about strong enough to dislodge a few roof tiles or maybe uproot a small tree, to EF5, defined as incredible damage, and is strong enough to throw cars, trucks, and even railway carriages over a mile. So there's not really much you can do to modify a car to withstand that.
Luckily, the team aren't daft enough to go anywhere near an EF5. An EF3 is far more common and as severe as they'll need to penetrate to get their data.
800, 1,000 pounds, 2,500 pounds, 4,000, 5,000, 4,500. Now we're at 5,200.
Rarely has counting been so thrilling.
5, 6, 7, 6,000 pounds, 6,120. Yeah.
Okay, that's a solid EF3. 145 miles an hour wind.
With no anchoring or nothing, F3.
Tug test at EF3. Tick. Now, to shoot some wood. Russell's air cannon can fire a fence post at 200 miles an hour, which is what a tornado can do. The team want to see if a driver sitting in this cockpit will be in any danger of being skewered. Please note, whether you own a vehicle with 1/4-inch steel plating or not, firing any object at it is extremely dangerous and not to be attempted. Test over. Time to see the result.
The coating where it hit this weld here and it caused the stick to split there, build the coating up in that spot, I can fix it. When you're in it, in an event, this is where your head's at. If debris penetrated that, it would kill them. It'd be horrible.
So despite the odd scratch, it looks like the puncher is nearly ready for some real tornado action. The question is, when will that be? Oh, possibly quite soon. But there is a vehicle that can take everything nature can throw at it. And it's in the Russian wilderness. 6.5 million square miles of arduous terrain, deep swamp, dense forest, frozen wastes. Few choose to travel in this unforgiving landscape. And those who do know there's but one way to do it. Massive wheels. Russia accounts for less than 2% of the world's population, spread over a territory spanning more than 1/10 of its landmass. Getting between the more remote communities can be a bit challenging, unless you have one of these.
The Sherp is one of those vehicles that looks like it could only have been invented in Russia. They have a lot of undeveloped territory in Russia, a lot of mining and logging and other operations in very remote areas without roads. They've got to cross rivers. So here's a vehicle designed to go almost anywhere in almost any conditions.
Designed by a mechanic from St. Petersburg as a vehicle to transport equipment and personnel in extreme environments, it's what you get if you cross an off-roader, a tank, a paddle steamer, and a tin of sardines. It's all about those humongous wheels. 1.6-metre wide tyres, positioned right at the car's corners, can negotiate obstacles a metre high. And they're adjustable.
One of the ways in which it accommodates the different terrains is it uses varying tyre pressures. They use exhaust gases which feed into the tyres. It can either inflate or deflate the tyres as they're going along to negotiate tricky obstacles.
Deflating the tyres means more surface area in contact with the obstacle, and so more traction to get over. But with wheels so big for the car, how do they turn? Well, they don't. The wheels on one side can be driven at a different speed or in a different direction to the wheels on the other side, which causes them to skid in a tight circle, which turns the vehicle. But what about when that ice melts? Aren't you going to need a boat? Not really. Those 800-litre tyres are more than buoyant enough to help you float. Even with a bunch of lads trying to sink you. And that weird tyre tread pulls it along a bit like a paddle steamer. Nevertheless, land or water, you won't be breaking any speed limits.
This vehicle can drive on roads, but not very fast. It can float and move through the water, not very fast.
In fact, it tops out on land at a rather leisurely 28 miles an hour, and less than 4 miles an hour on water. And it can be yours for just £73,000. But let's end on a positive, eh? Remember, this is also a tin of sardines. You see, despite having substantially more wheel than body, the car can carry at least 8 friends. Room for one more? Yes, of course there is. 9 close friends. So there you go. Russia's unnavigable terrain, now more navigable. But at less than 4 miles an hour, it's going to be a long journey, chaps. This is Ivan from San Diego. 73 years old, an easygoing nature, and loves long drives in the country. This kind of country. Ironman Ivan Stewart is the retired legendary 20-time winner of the world's wildest off-road race series. He may be made of iron, but how do you build a car fast enough and still tough enough to take this? The Baja 1500 take place every year on the Baja Peninsula, Mexico. Since 1967, vehicles of different classes, from motorbikes to high-performance trucks, have taken part in the race. The Baja 1000 alternates between an 850-mile loop and a point-to-point from Ensenada to La Paz. In either case, it's wild.
The Baja 1000 is unlike any other race. It's almost like anarchy in the desert. You've got these drivers driving these incredibly high-performance trucks at enormous speeds in very dangerous conditions.
If you don't like a little pain once in a while, this isn't the form of racing for you, because you're going to get sore and you're going to get tired and you're going to have cactus in your hand. And it's going to be nonstop. When the clock starts, if you're going to finish and it takes you 50 hours, you're going to be driving for 50 hours.
And you can't let your concentration drop. Even the crowds are keen to get in on the action, and not in a helpful way.
you've got these spectators all over the place, very few rules, no guardrails. They can walk onto the course if they want to. The whole mix is kind of insane.
Entry requirements for the race are relatively relaxed, but rather than turn up in your family runaround, you'd be well advised to follow the pros. And get yourself one of these. The near indestructible Baja truck.
Building a Baja vehicle is a classic engineering challenge because you're trying to satisfy contradictory goals. On the one hand, you want the fastest, lightest vehicle you can have. On the other hand, you want something that's tough enough to survive the pounding.
You can either use standard materials that are quite heavy and thick sections, or you can use more sophisticated materials that are more expensive, but perhaps have higher strength or higher fatigue resistance.
The cost of high-strength, lightweight materials means this is a sport where you need a bit of cash.
So this is one of the power plants, about $70,000 for one of those.
Correction, a lot of cash.
Well, if you're thinking about buying one of these extreme race cars, you're talking about $350,000 to $600,000, $700,000.
Even more cash. And one area where you definitely want to spend big is suspension.
You might be going through potholes, so you need really good, rugged tyres. But you also might be going over jumps, so your vehicle's got to be able to withstand the impacts that it sustains.
But you can see that this distance from here all the way up to this bump stop, and that compresses, you're looking at 34 inches. There's the shocks and the springs for the rear, and these are all adjustable for different types of terrain. So you may want to increase the bump travel or the bump suspension, or you could loosen it up, depending on how fast the course is.
In the Baja 1000, it's not just natural bumps in the road you need to worry about. Those spectators regularly build booby traps.
I had just about every problem that you could imagine, from somebody digging ditches across the road, throwing rocks in front of me, changing the arrows, and they'll always build some sort of a jump because they're a little bit bored. I was racing a race in San Felipe 250, and they built this ditch across the road. I mean, it was full of furniture, had couches in it, and there were several people that had rolled over right after. So I remember hitting that one, thinking luckily that, gosh, I survived that. You know.
So with ditches and furniture to clear, serious suspension is a must. But you do also need to think about what you don't need.
For the optimisation of the vehicles, it's about understanding which components are essential, which components you can lose. Quite often you see vehicles that are skeletonized, and that's because that particular part of the body isn't essential to the safe operation of the car or its speed.
Well, one of the other things you'll notice that these race trucks don't have a windshield. I had an owl come into my windshield one time and hit me in the head.
That's right. He said an owl.
If it's fog or if it's mud or debris or rocks, it's going to come in through this area.
So that's all you need to build a Baja racer. $500,000. Booby trap-proof suspension. Oh, and maybe a helmet for the owls. But sometimes chaos is just another way of being organised. This is not the starting line of a motorbike race. It's just a regular morning commute in downtown Hanoi. A city that's home to 7 million people and 5 million motorbikes, nearly one per person. The council wants to cut that number down to 0. Good luck. Hanoi is the capital of Vietnam, a country that's had a love affair with two-wheeled motors for over half a century. The out-and-out favourite being the lightweight 50 to 125cc Japanese motorcycle. But there's a problem. All those exhausts are highly polluting. So local government wants to ban the bikes. Hanoi hopes to be like other modern cities and get at least half of commuters using public transport by 2030. Which means improving bus routes and a multi-million-pound rapid transport system. But until then, there is method in this motorcycle madness. An average wage of around just £1,500 a year in Vietnam means that for most, two wheels are the only affordable option. And the city's exploding population is making even the wide roads congested for cars, but not so much for bikes.
Motorbikes take up a lot less space than cars. They're very maneuverable. They can be parked easily. Mostly they want to carry 1, 2, maybe 3 people and some cargo, ludicrously large cargoes as well.
This alternative to a family MPV is not only more wallet-friendly, but more fuel-efficient. And why buy a van when, as long as you have a superhuman sense of balance, even a moped makes the perfect workhorse? In fact, in a nation that has one of the world's fastest-growing economies, two-wheeled transport might actually be intrinsic to its industrious nature.
While it looks chaotic, it's incredibly efficient. Everyone keeps moving, finds a way around each other.
Efficient mobility is about flow, where everyone's moving around and through each other all the time.
So maybe other modern cities should be more like Hanoi. Well, some are.
Cities like Amsterdam and Copenhagen, they design streetscapes that are very open.
And it's the absolute cutting edge thinking about mobility planning in Northern Europe. They have very open streets, pedestrians, trams, bikes, cars, all mix in what seem like quite unplanned ways. But what it does by creating this open street is it forces all the road users to see each other.
The evidence shows that it's actually extremely safe because everyone in that space is highly aware of everyone else.
Back on the Hanoi highway, here's the theory in practice. This lady here didn't even break a step. So it may not be the greenest mode of transport, but there's theory to suggest it may be more efficient and safer than you think. Well, 5 million bikers can't be wrong. Perhaps the most extreme thing you're going to do in your car is visit the parents-in-law. But your motor can do a whole lot more, because it's been tested almost to destruction just so you can pick up the kids without fear. California, Dubai, Sweden, the most extreme car testing grounds on Earth.
Most cars are designed to be used in reasonably ambient conditions, but that's not true of cars that have to operate in the extreme north of America, Canada for example, or Russia, the desert regions in the Middle East. So car manufacturers will test their vehicles under a range of different conditions.
If it's heat you want, the Mojave Desert, California is ideal. It's home to Death Valley, where the highest ever air temperature was recorded, a flesh-searing 56.7 degrees Celsius. Go for a drive here, and you're going to want that aircon working. But it's right here in the Mojave, and also the equally rubber-burning deserts of Dubai, that manufacturers heat test your motors before you buy them. Miles of dunes and track are a proving ground for off-roading capabilities, engine and transmission cooling, and bodywork.
They might want to check on the sealing capability of cars, because obviously if cars are very hot, things will expand, and so the clearances that they have will change.
In a £44 million facility in the Mojave Desert, manufacturers even leave their parts out under the scorching sun to measure resistance to the near 50-degree heat.
Paint depends on the temperature that it's exposed to as how effective that coating is. They may use different paint solutions for different countries to give you better UV protection in the paint in hotter countries.
But your car doesn't just suffer in the sun. It can also be affected by extreme cold, like you get here in Arjeplog, Sweden, where temperatures sink to minus 20 degrees Celsius. Here, across 20 miles of track and road, on land and frozen lake, manufacturers test traction and braking systems in extreme cold conditions, helped by a snowmaker keeping friction low to give your ABS a workout.
The way in which you apply pressure during braking can be modified. So if it's very icy, you may deploy a different braking system if it's very hot or if it's very sandy. They can test different tyres and the grip that you get. So it gives them an opportunity to really understand the vehicle.
So whether it's chilly or toasty outside, remember, your car has probably been through a lot worse. But some environments are so tough, you don't need a car, you need a dinosaur. The Hambach coal mine. The biggest man-made hole in Europe, over 32 square miles. But that's a record breaker for another programme. The region's mines are home to the biggest vehicles on planet Earth. Hambach is one of 3 mines located in a 1,000 square mile patch of West Germany. This area has produced nearly 100 million tons of lignite in a single year. It's a low-grade coal, used predominantly to fuel power plants. In the early days of the 20th century, when demand was far lower, lignite was mined largely by hand, and the biggest machines looked something like this. But as demand increased, machines got bigger. No, bigger than that. This is the Baja 288.
The bagger is used for what's called open pit mining or strip mining, where you have a seam of coal, but over it you have 10, 20, 30 feet of rock and soil that first needs to be removed. And that's an enormous amount of work if you're trying to do it with individual bulldozers or shovels and trucks. With this bucket wheel excavator, you can come in and dig up massive amounts of material in a very short amount of time.
Germany is one of the global leaders in clean fuels. But 1/10 of its energy is still supplied by lignite power stations. Lignite has been called a dirty fuel because when it's burned, it releases more CO2 than any other fossil fuel. Mining it on this huge scale has also come under criticism because it churns up large swathes of countryside. The 288 is one of 2 near-identical giants. Standing at nearly 100 meters high, 220 meters long, and weighing in at over 13,000 tons. Some might argue it produces huge economies of scale and efficiency.
Each bucket is big enough that a tall man could stand in it. As it scoops up that rock and soil, it dumps it on a conveyor belt so that it can be moved to the back of the excavator and dumped somewhere else in the pit. The boom can also move itself, so they can gradually swing it, and then when they've worked that area, the entire excavator can creep forward on those giant tractor treads. So the whole thing moves through the pit like some kind of prehistoric dinosaur.
With each of those 18 buckets able to scoop up around 6.5 cubic meters of earth. It's a dinosaur with a voracious appetite.
It consumes vast amounts of energy to operate it. So it takes nearly 17 megawatts of power to actually operate the bagger. And the bagger takes its power from the power plants that it's supplying. So it's very useful if you're in an area where you've got that energy supply.
Time was, in order to go mining for ore, you took a pickaxe and you just swung it and you dug and then you found something. These days, that does not do. This is like having a million workers with pickaxes all combined together into one gigantic, enormous machine.
Rather than a million, it can take just 5 people to operate the bagger. It also reduces the need for a horde of other vehicles.
Having lots of trucks going on and off site can be a very complex operation to coordinate. If you can remove the material in a different way using conveyor belts, that's more efficient and it's also more safe.
In just one day, the bagger can dig up 240,000 tons of earth.
As expensive and elaborate as this machine is, it's still much less expensive to operate than hundreds of individual excavators. People are more expensive than technology. You often see systems like this built precisely so that you can run a mine without the hundreds and hundreds of workers you would need to do it more old-fashioned way.
It's a machine that works on an economy of scale unlike any other. For these mines at least, size does matter. The bagger is the world's biggest vehicle and the world's most extreme.